Hey guys, so we're going to be reviewing solutions in acid and bases in Chem Honors. So the first thing you need to know are what solutions are. So a solution is made up of the solute and the solvent. So you can think of a saltwater solution. And in a saltwater solution, the solute is going to be your salt. So a solute is what dissolves in the solvent. It's typically a solid, but later on in this unit, you'll learn about acids and bases. And then the solvent is what dissolves the solute. So you can think of water. So in this unit, your solute is typically just going to be water. Okay, and then there are three types of solutions. There's an unsaturated solution, which is when your solution can hold more solute. There is a saturated solution, which means the maximum amount of solute is inside the solution. And then there is supersaturated, and that means there's more solute than the solution can hold, and this typically happens at high temperatures. So here are your three types of solutions. You can see this unsaturated solution has like a smaller amount of solute, so it can hold more solute. This saturated solution has a decent amount of solute, and over here you can see that it can't hold anymore for it to dissolve. So this doesn't necessarily mean like when you put in solute, like it just can't go in. What this means is that it just doesn't dissolve. And then supersaturated, you can see that there's extra solute. Okay, so you can think of salt, and then you can think of water. And so this is what happens in a dissociation. What happens is the sodium and the chloride atoms and sodium chloride will interact with the oxygen and the hydrogen molecules in water. So we know that the oxygen has a partial negative charge and the hydrogens have a partial positive charge. So what happens is the negative ends of the solute interact with the positive ends of the solvent, and in this case, hydrogen will interact with the chloride, and then these molecules of water will surround the molecules of salt to dissociate and dissolve the particle. And so that's modeled in this over here. So on your test, if you're asked to like draw a diagram of like the dissociation, what you draw is, first of all, if it's an ionic compound. Ionic compounds are solid. So you have to draw them in a lattice structure. So over here you can see it looks like a solid, right? It's a square. And then what happens is when you place this in water, the atoms or the molecules will start to dissociate. So over here you can see that this chloride atom is separate from this sodium atom. And then you can see that the positive charges of water are interacting with the negative charge of the chloride, whereas the negative charge of the oxygen is interacting with the positive charge of sodium. So you just have to remember to do that. Okay, so gas solutions. So there are a few things you need to know about gas solutions. The first thing is that molar mass, so gases with a greater molar mass will tend to be more soluble in liquids. As for temperature, solubility decreases with temperature, and pressure, solubility increases with pressure. So the relationship with temperature. In solids and water, as temperature increases, solubility will increase. For gases and water, as temperature increases, solubility decreases. So let's think about this. When you're putting a solid in water, when you raise the temperature, the solid can uh, dissolve in the water quicker. So you can think about this like with sugar and water. When you're putting sugar in cold water, you're going to have to stir it for a little bit for it to dissolve. If you're putting sugar in hot water, it dissolves right away. So that's a way for you to think of it. So here's a solubility curve. You're going to need to understand how to like break this curve apart and like analyze it. So you could be asked at what temperature is um, potassium chloride at, I don't know, 50% solubility. or like when is it at, 50% solubility. So 50 grams dissolved in water. So that's at like 75 degrees Celsius. So yeah, you're just going to need to know how to read this chart. Okay, so you could also need to understand when something is saturated, unsaturated, or supersaturated on a solubility curve. So you're going to follow the line of the curve similar to the line over here. So this is like the trend. So you're going to follow this trend. If the dot is above the line, it's supersaturated. If the dot is on the line, it's saturated. If the dot is below the line, it is unsaturated. Okay, so dissociation. So dissociation is the process of breaking down a compound into particles, and in this case, ions. So a dissociation reaction is usually reversible, and all ionic compounds will dissociate into their ions when they are in water. And then this is very important to understand and remember. So diatomics are not written in their diatomic form when they're ions, but rather their subscript becomes the coefficient. So let's say you're given the bromide ion and it's in a dissociation. You're not going to write it as Br2 minus, you're going to write it as 2Br minus. And again, in a dissociation reaction, what happens is you're taking the solid and it's going to turn into an aqueous solution of ions. So this is actually wrong. This should be NaCl, but basically NaCl will dissolve into Na plus and Cl minus. Okay, so here are some examples of how to write a dissociation equation. So right here you're given the molecule, and it's dissolving into H plus and Cl minus. Notice how none of these are written in their diatomic form, and that's just because you're started off with HCl, so you don't need to balance it. And then over here, you're given sodium hydroxide, and it dissociates into sodium ion and a hydroxide ion. Okay, electrodes. So electrodes are a substance that can conduct an electric current when dissolved in water. So strong electrodes will completely dissociate in an aqueous solution and they conduct an electric current. And then weak electrodes do not completely dissociate in an aqueous solution, and non-electrodes will not dissociate and will not conduct electricity. Okay, concentrations. So I think you guys know what concentrations are. So it's just basically like the amount of solute inside of a solution, and that's the concentration. So when there's more solute, it's more concentrated. When there's less solute, it's less concentrated. So concentration is the same as saying molarity. So you could see it either way. You could say calculate the concentration or calculate the molarity. And it's represented by M, a capital M. And it's sometimes in brackets. So if you ever see like calculate the hydroxide ion and then it has brackets, that's basically saying calculate the hydroxide ion concentration. So it's basically asking you to find the pOH. Okay. And then, but I'll cover that later when we get to acid and bases. Okay, and this is the formula for finding molarity. If this confuses you, just remember molarity is equal to moles over liters. That's how I like to think of it. Molarity is always moles over liters. So it's going to be moles of solute, okay, just moles of solute over liters of solution. So your moles of solute, that's going to be like you're told to calculate the concentration of salt in water. You're first going to find the moles of salt, and then you're going to divide that by the moles of the entire solution. So if they gave you the amount of liters in water, and then they gave you the amount of liters of salt. And it's asking you to find the solution, then you're going to add those up, and then you're going to divide the moles by that sum. And then if you're given two values for molarity and then one value of volume, and you're told to find the volume of the second molarity, then you would use this M1V2 it should be M1V1 equals M2V2. So yeah, okay. Basically, it's just like if you're given 3 and you're missing 1, you would use this equation. Okay, concentrations. When you're given kilograms or grams instead of liters or milliliters, you're going to do molality, and that's represented as a lowercase m. So molality is moles of solute over kilograms of solvent. So remember, molarity is when you take your liters of solution, so it's the entire thing. But molality is your kilograms of solvent. So you're not going to add your solute to the solvent. You're just going to keep your solvent. And in this one, so you're typically given a solution in grams, so you would actually need to convert to kilograms. So remember your units. And remember, this is lowercase m. Okay, so that's it for these notes. Now let's move on to PowerPoint. Yeah. Okay. So we're going to be going over acids and bases now. Okay. So this is Miss Sandstrom's slideshow. I didn't have time to make another one, so we're just going to use this. Okay, so acids and bases. So there are 3 theories. There's your Arrhenius, your Bronsted-Lary, and your Lewis. So with Arrhenius, it's when the acid in an aqueous solution, it donates a hydroxide ion. So the acid is what donates a hydroxide ion, and then the base is what donates a hydronium ion. So this is the Arrhenius theory, that the acid will donate a hydrogen ion and the base will donate a hydroxide ion. So if you look at this example over here, you can see that this is your acid, and it's going to turn into a hydroxide ion and nitrate. So this is nitric acid. And then over here, you have your base. So this is sodium hydroxide. And in the presence of water, so in an aqueous solution, it's going to donate its hydroxide ion and become hydroxide and sodium. So your second theory is your Bronsted-Lary theory. So this is when your acid is a protein donor, so it donates a proton. So your acid is a proton donor, it donates a proton, and your base is a proton acceptor. It will accept the proton that the acid donated. So a conjugate acid is the species formed when the proton is added to the base. And your conjugate base is the species that forms when your proton is lost by an acid. So we're going to go over this. So right here, so another thing you need to know is that water can be an acid or a base in a Bronsted-Lary equation. So water can act as a base or an acid. So if you ever see HCl and you see water and you're confused because those are both acids, well, water can actually act as the base. Whereas if you're given like sodium hydroxide and water, your water is going to be your acid. But in this particular equation, your base is going to be water. So this is your acid. It's HCl, hydrochloric acid, and it's reacting with water, your base. And what happens is, since this is a Bronsted-Lary equation, your acid is going to donate that proton, and it's going to donate it to your conjugate base. So your conjugate base is what is formed when your proton is donated. So since Hydrochloric acid lost the hydrogen, it just forms chloride ion. This is a chloride ion, and your conjugate base is going to be the chloride ion. And then your base will accept that hydrogen atom, and it will form hydronium. So hydronium is H3 plus ion, hydronium ion. Okay, so this is just going over conjugate acids, conjugate bases. Let's go over this one. So in this case, your acid is water. So in the previous example, your base was water, and this one, acid is our water, or water is our acid. So this acid is going to lose a hydrogen, and what happens is when water loses one hydrogen, it's going to form hydroxide ion. And so that's why your conjugate base is your hydroxide, because this is what happens when water loses its proton. And then your base is going to accept that, so it's going to become ammonium. So yeah, it's an ammonium ion. Okay, so your third theory is the Lewis theory. So the Lewis acid is any substance such as the hydrogen ion that can accept a pair of non-bonding electrons. So a Lewis acid is an electron acceptor. Okay, Lewis acid is an electron acceptor. And then a Lewis base is a substance such as the hydroxide ion that can donate a pair of non-bonding electrons. So an Lewis base is an electron donor. So in the previous theories, the acid was like a proton donor. In this case, we're talking about electrons. Okay. So things to know about acids. Acids are proton donors. They have a pH of lower than 7, so anything lower than 7 is acidic. As for bases, they have a pH greater than 7, so anything greater than 7 is basic. So some common acids are sulfuric acid, nitric acid, phosphoric acid, hydrochloric acid, acetic acid, and what was that? Carbonic acid. And then bases, some common bases are sodium hydroxide, potassium hydroxide, calcium hydroxide, sodium bicarbonate, magnesium hydroxide, and ammonium hydroxide. So something to remember is that acids will always have an H, bases will always have an OH. That's how you can identify them. Okay, so the strengths of acids and the strengths of bases. A strong acid is when the acid will dissociate completely in water. A strong base is when the base will dissociate completely in water. So the stronger the acid, the lower the pH. The stronger the base, the higher the pH. Okay, so let's say you're given a weak base. The pH will be closer to 7, and what that means is it doesn't dissociate completely in water. Yeah, so a weak acid and a weak base does not dissociate completely in water. Okay, so dissociation of water. Water is really hard to dissociate. So that's basically just the takeaway from that. And what you can know about like water is like when you're having a dissociation and water acts as the acid, what happens is you're always going to form a hydroxide. So when water's the acid, you're going to form a hydroxide. When water's the base, you're going to form hydronium. Okay, so this slide is just how to calculate pH. So as I said earlier, pH is basically the concentration of your hydronium ion or hydroxide ion or your concentration of your hydrogen ion. So what you do is the dissociation constant is your Kw. So Kw is going to be equal to concentration of hydroxide times the concentration of hydrogen, and it's equal to 1 times 10 to the negative 14th. So the concentration of your hydrogen ion is the same as your concentration of your hydroxide ion. Okay. Oh, so it's not telling you how to do this, but basically what you would do is you would just plug into your calculator the negative log of the concentration, and that's how you find your pH. So your pH is equal to the negative log of the concentration. If you're told to go from pH to finding the concentration, you would do the inverse. So you would do 10 raised to the negative pH to find your concentration. Okay, let's see. So measuring the pH, yeah, so the pH is indicated by concentration of hydroxide or hydrogen. So the midpoint is 7, that's neutral, 0 is the most acidic, 14 is the most basic. Okay, calculating your pH is the negative log of your concentration of your hydrogen. Okay. Okay, so what you're going to do is whatever your pH ends up being, you're going to look at that power. So in this case, the power is negative 3, that means your pH is 3. Over here, you're looking at your power. If your pH is 7, your power is going to be negative 7. And remember, when you're finding the concentration of your hydrogen ion, that's your pH. But let's say you're given hydroxide. Once you find your concentration of your hydroxide, you're going to subtract that from 14. And that's how you get your pH. Because let's say you calculate the concentration of hydroxide, but the question is asking for what's the pH. If you give them your concentration of your hydroxide, that's wrong. That's your pOH. You need to subtract your answer from 14 if you're given your hydroxide concentration. But if you calculated pH, you don't need to do that because that's right, you just got your pH. Okay, so I think you did this table. Just make sure you understand how to do that. If you need help, just let me know. And that's basically it. Okay, bye guys. Good luck on your exam. Sorry, neutralization. Let's just go over this really quick. A neutralization reaction is when you're given a base, it reacts with an acid, and it forms salt and water. So in this case, your base is your sodium hydroxide, your acid is HCl. Notice this is a very strong base, very strong acid. So it's going to do like a double displacement, and you're going to get sodium chloride and water. In a neutralization reaction, you're always going to get an acid and a base as your reactants, and your products are always going to be a type of salt and water. Okay, so yeah, this is what I was talking about. This equation, your molarity of your acid times your volume of your base equals your molarity of the base times the volume of the base. This is when you're at equilibrium. So this means the number of moles of your acid is equal to number of moles of your volume of your base. So you don't really need to know what equilibrium is. You just need to know that you can use this equation when your moles of acid is equal to your moles of base. That's how you can figure out your volume of acid or volume of base. So titrations. Titrations is used to find equilibrium. So you perform a titration in order to determine what the volume of a solution is. So basically, the whole purpose of a titration is to get equal moles of base and acid, so in order for the indicator to show that the reaction has occurred. So the titrant is the solution of the known concentration. The analyte is the solution of the unknown concentration. So the titrant is what's in your tube, and your analyte is what's in your beaker. Equivalence point or endpoint is the point at which the indicator changes color. Okay, so make sure you just understand this. Lab equipment. Okay, now that's all. Okay, good luck on your test, guys. Bye-bye.